Hi folks, today I bring you the LM8361, a clock that can have a time base of the 50 or 60 Hz. It can directly replace the S1998, and to do so we only need to take into account whether the pin 37 is used or not in the S1998A version, and whether the IC's power supply is around the last 12 volts DC to be able to receive the LM8361. Since two videos have already been made for the S1998, I recommend watching them as a complement to the LM8361. Once again, we are dealing with a PMOS integrated circuit from the late 70s, and therefore it requires great care in its power supply regarding the polarity. Its power supply range is less 12 volts DC with a tolerance of the more or less 2 volts. This power supply value is much lower than that of the S1998, which has a maximum of the less 29 volts DC, or the LM5387AAN, which can go up to less 26 volts DC. We warn you to be careful when it comes to a direct replacement. Both the S1998 and MM5387AAN can directly replace the LM8361, but the opposite requires a careful check of the power supply voltage, since the LM8361 should not be subject to the more than less 12 volts DC. This integrated circuit was very common in the B-side clock radios, as it allows the setting of a wake-up and sleep time. In my opinion, it is a shame that in the 24 hours format configuration, the ability to use 1 Hz output from the column used in the hours-minutes separation is eliminated. To overcome this flaw, I will use a CD4011 to generate a pulse and thus produce the blinking of the two dots in our VFD. It could be a monostable transistor or even an NE555, but since the 4011 supports between 5 and 18 volts, this also serves to highlight the care that must be taken to power both integrated circuits. Don't forget that the LM8361 is a PMOS from the 70s and the CMOS is newer, so it was VSS as a 12 volts and the VDD as 0 volts, while the other, the CD4011, is the opposite. Pay close attention to these details to avoid destroying the integrated circuits. Today we are going to go from the 60 Hz provided by the MM5369 we have used on the S1998 to the 50 Hz provided by the electrical network. To do this, we are going to use a 2 times 7.5 volts AC transformer with a half wave rectification per winding. This method will result near of the 9.5 volts DC after filter with a capacitor of the 470 microfarads, 25 volts. Since we are going to have to deal with the electrical network, I emphasize the importance of the isolating any conductor on the primary side of the transformer, as the voltage from electrical network is very dangerous for humans. As a precaution with the port of our LM8361, we are going to use a 2.2 nanofarads capacitor and a mega resistor both in serials to provide the 50 Hz 2-hour clock on the pin 35. Do not forget that the change in the time base from the 60 Hz to the 50 Hz implied changing the resistance of the pin 36 to the 0 volts. I would like to point out that selecting 60 Hz implies a resistance to the plus 9.5 volts DC, while at 50 Hz the resistance is connected to the 0 volts on the pin 36. Note that I'm not using the names VSS and the VDD to avoid confusions. The fact that we are using a transformer with two windings allows us to obtain a full wave rectification at the central tap, but it is still possible to extract 50 Hz from the end of the one of the windings. I connect the sector now. The system is blinking after the power failed. We need press the hours or minutes to stop the blinking. You can see here the blinking of the LED. This LED belongs to the two NANDs of the CMOS to generate the blinking of near of the 1 second, okay? The same pin provided the power up of the LED is connected to the resistor belongs to the segments of these two dots in the middle. This LED here is connected to the 1 Hz output from the LM8361. And you can see, depending of the configuration of the segment here in the first digit, the LED is on or off. Now will be off at 10, okay? Because this LED is connected to the output of the 1 Hz from the LM8361 and belongs to the digits A and D from the digit of the 10 of the hours. Because I have two NANDs free in the CD4011, I use these two NANDs to generate a tone used as alarm. To test it, I will check the time configured in the alarm is 1933. Okay. And now I'm waiting the skip of the minutes, and the buzzer is ringing because reached the time of the alarm, and for stop the alarm I implement the input with the name the stop the alarm. I proceed also with the test of the sleep or the output of the port to sleep with a connection of the one LED. In this case is 59. Okay, and now after skip the minute, 1 minute, the LED will be off. Okay. because I connect this LED to the output to the sleep. To connect the VFD, I proceed with a parallel connection between segment by segment to the VFD. The original display present in the LM8361 normal is display of the LEDs. Sometimes the first digit is not complete, but here is not relevant, and is not easy find a clock, a radio clock with a LM8361 and VFD display.